Next up, we have another witness for the band. His name is Esteban Chiriboga. The last name is spelled Chiriboga, and he is an environmental specialist at the Great Lakes Indian Fish and Wildlife Commission.
Okay, thank you. Good afternoon, everyone. So yes, my name is Esteban Chiriboga, and I'm going to talk a little bit about the work that Glyphlix has been doing since the PolyMet project was first proposed, as well as some recent mapping in support of Fond du Lac Band's will affect submission to EPA. So I've personally worked at Glyphlix environmental section for almost 25 years now, and one of my primary tasks at Glyphlix has been to characterize the effects that large-scale land use alterations have on natural resources that tribal members depend on. And I use geographic information systems as probably my primary tool. And I've worked on various aspects of the proposed PolyMet mine since it was first proposed almost 20 years ago. So we're an intertribal agency of 11 Ojibwe tribes in Michigan, Wisconsin, and Minnesota. Glyphlix's primary charge is to exercise delegated authority from those tribes to implement various federal court orders regarding the exercise of treaty reserve rights to hunt, fish, and gather in the ceded territories, which, as you can see on this map, as well as earlier today. As part of ensuring the continued existence of treaty reserve rights, the health and sustainability of ecosystems must be protected and maintained. Fond du Lac Band is one of our member tribes, and it is located in the 1854 ceded territory right up here and downstream, as you've already heard from the proposed mine. Some of the work that I've done recently is really geared toward illustrating the hydrologic connection that exists between the Iron Range and the proposed PolyMet area and the Fond du Lac Reservation. And I think I've done plenty of that already today. I also work to provide wetland type and acreage data for our experts that will be speaking after I do. And I'm going to try and describe some of Glyphlix's past work, characterizing indirect impacts to wetlands from the proposed PolyMet mine. Just for disclosure, all the wetland and hydrography data that you will see today was created and is maintained by either the state of Minnesota or the Federal Emergency Management Agency, or FEMA. The mine features that we depict on the maps were created by PolyMet, and I will be talking about a USGS groundwater model, and all the files and reports related to that model are available on this link. So, and again, as you've heard already, establishing a hydrologic connection between mining at the headwaters of the St. Louis River and points down gradient seems relatively straightforward. This middle range purple area here is the St. Louis River watershed, and all of the mine pits, tailings, basins, and stockpiles that are located in this basin send their effluent and their contaminant load downstream. These contaminants do include mercury and sulfate, which are very important to the conversation today. Notably, the green rivers and lakes that are depicted on this map are on the stage 303D list of impaired waters, and those impairments do include mercury. You've seen this map before, but if additional evidence of the hydrologic connection beyond simply watershed processes is needed, water quality sampling provides this. As Nancy mentioned, this map shows some work that Scott Cardiff did as part of his successful PhD defense now, using MPCA sulfate data. The large yellow dots located up here next to the Iron Range are the source of the sulfate, and the larger the dot, the higher the sulfate level in the sample. The dots get progressively smaller with distance from the mines as the contaminant plume is diluted. This concentration and distance relationship for sulfate is statistically significant. The dark blue dots on this graph are MPCA samples from the St. Louis River, and the regression line indicates that the mining water quality signal persists downstream of the mines for about 200 kilometers. So given the hydrologic connection, I'm going to turn to some of the mapping work of riparian and floodplain wetlands along the St. Louis River and the two tributaries that link the area of the proposed PolyMet project with the Fond du Lac Reservation. So those are the Embarrass and the Partridge Rivers. And you will hear more about this from the next speakers, but what we're doing here is identifying the wetlands that are hydrologically linked to the rivers, because these are the wetlands that are affected by the sulfate load coming from the mining areas. The combination of the sulfate load, the mercury load, and seasonal or occasional wetting and drying processes in the wetlands result in enhanced methylation of mercury, which is a primary concern for tribal members, or in fact any group that engages in subsistence fish harvests. So the next slide that I will show will be number 25 here. We're going to zoom in to this map on the index. A section of the St. Louis River just upstream of the Fond du Lac Reservation. So again, the St. Louis River runs down the center of the map, and the northwest corner of the Fond du Lac Reservation is on the bottom right corner. Again, the wetland polygons depicted come from the latest data set from the state of Minnesota, and both the riparian wetlands and wetlands that are connected to the 100-year floodplain are depicted. Riparian wetlands are those that immediately border the river, like the purple wetlands that you see right here. The HGM wetland classification that the state develops is helpful here because by definition, the low-tick wetlands, the purple ones, are part of the river ecosystem and have river water flowing through them. As I mentioned, we also mapped wetlands connected to the 100-year floodplain because while these wetlands may not have a constant hydrologic connection with the river, they can still occasionally receive water with the higher sulfate and or mercury load and still be a source for methyl mercury to the St. Louis River during periods of flooding. Okay, so I'm now going to focus a little more on the area surrounding the proposed PolyMet project and look at the hydrology and wetlands. So on this section, I hope everyone can see the cursor. This is the Embarrass River on the more or less the left-hand side of the figure. The yellow areas are wetlands that are connected to the 100-year floodplain of the Embarrass River. In the center, this large gray feature is the existing taconite tailings basin that PolyMet proposes to reuse and deposit their tailings on top. We have the red areas are wetlands to the north of the tailings basin. There's some orange wetlands here on the western side of the tailings basin, and I'm going to be talking a little more about those here in a moment. So zooming in to the area north of the existing taconite tailings basin, these wetlands, and in fact the entire superficial aquifer between the tailings basin and the Embarrass River, is saturated with high sulfate tailings water that has been seeping out of the facility for decades. Water enters these wetlands and moves via shallow groundwater, and a lot of it, I am having trouble with this, and a lot of this water enters the Trimble Creek and this unnamed creek here, which are tributaries of the Embarrass River. Similar condition exists on the west end of the tailings basin. Water flows out of the tailings basin to these surface water features here and move toward the Embarrass River located on the top left corner of the figure. This stream here is officially an unnamed creek, but we have nicknamed it Rice Farm Creek because this area of the figure used to be a wild rice farm. It then became a wetland mitigation site, and you can see here the constructed berms that were put in to induce flooding and create new wetlands. And I believe this site is now a wildlife management area. So this, I think, is a perfect example of the types of existing methylmercury generating environments that we find in the area. Having an area that is purposely flooded to build wetlands and then having a stream with high sulfate water running through it is exactly the types of conditions that should be avoided. So these features that I've mentioned at this point are all existing contributions to the sulfate load in the St. Louis River. I do want to point out this area in red on the bottom right-hand corner of the figure. It's the proposed location for PolyMet's hydrometallurgical tailings disposal facility. These would be the most highly reactive tailings that the project would generate, and they have to be segregated from the environment in perpetuity in order to avoid very serious water quality impacts. I would point out that there is a hydrologic connection between this site and Rice Farm Creek via wetlands and ditches that are formed on the western end of the tailings basin. Historically, there used to be a creek that ran or originated right in the middle of this, what is now a large wetland area. The creek has become buried by tailings over time, but this water in this catchment area still is finding its way to Rice Farm Creek, to the Embarrass River, and on to the St. Louis River. And so this facility is a future concern should the mine be constructed. Next, we're going to take a look at the hydrologic connections and wetlands in the area where the mine pits and stockpiles would be located. So, Partridge River runs along the bottom of this figure, right, roughly through here. The pink color wetlands are the wetlands within that are connected to the 100-year floodplain of the Partridge River. These gray features over here are proposed mine site features. There are the 2 pits, some stockpiles, roads, and other facilities that have been proposed for construction. And this oval area of darker pink wetlands are the areas that could be affected by groundwater drawdown caused by the project. So at this point, and I'm confident that most of you in the room understand this process very well, but just in case, we wanted to give a very simple description of what we are thinking about when we talk about groundwater drawdown. So this very simple schematic provides a good look at this phenomenon as the mine pits would be developed. This dashed blue line that you see right here is the groundwater level and it would extend across this area prior to the construction of any mine pits. And this white box in the center is intended to represent the pits. As digging begins, groundwater surrounding the pits begins to flow into the new hole and needs to be pumped out in order for mine development to proceed. This pumping creates a cone of depression in the groundwater surrounding the pump. As the mine pit becomes deeper and more water is pumped, the cone of depression also becomes deeper and extends a greater distance away from the mine pits. So any surface water feature that is located in the area of this cone of depression then is subjected to a new downward hydrologic gradient that did not exist prior to any digging or any pumping at the mine pits. So at this point, I think it's important to provide some context for some of the history on this issue. Early in the project, Glyphlix and Fond du Lac and other agencies argued for using a quantitative method to determine indirect wetland impacts due to groundwater drawdown. And one of these methods has been called the Crandon method. So the use of this Crandon method has several advantages. It was used in the past by the St. Paul District of the Army Corps for their EIS on the proposed Crandon mine in Wisconsin. It is a quantitative method for indirect wetland impact prediction and combines a calibrated groundwater drawdown model with wetland delineations and detailed plant lists that are collected in transects across the wetlands of a site. This method identifies acres of wetland where groundwater drawdown impacts are reasonably foreseeable, which is a useful piece of information to have because then the Corps can require mitigation or other options to avoid these wetlands could be developed by the project proponent. Initially, the lead agencies, the Corps and the Minnesota DNR, rejected the Crandon method approach because of the mining company's assertion that the wetlands in the mine site were all perched bogs or disconnected from groundwater. Now, the speakers that are going to come after me are going to talk about this in more detail. I'd only say that the concept that wetlands are so disconnected from groundwater that no amount of drawdown can have an effect on their hydrology really isn't supported at this site by any available information. Now, when what we call the second DEIS process began, this is after the EPA gave the first DEIS its failing grade, the lead agencies convened a set of impact assessment planning, or IAP groups, and the goal was to improve the environmental analysis of the proposed mine. The wetland IAP group was tasked with providing recommendations to the lead agencies on a number of things, and the methods that would be used for predicting impacts to wetlands from groundwater drawdown were one of those topics. So the Corps wrote on July 1st, 2011, the final summary memo for the IAP groups. And that memo indicated that a quantitative assessment of indirect wetland impacts from groundwater drawdown using additional field data and a calibrated groundwater model, basically the Crandon method, was the recommendation from the majority of the agencies that participated in the IAP group. That included federal agencies, the MPCA, and several tribes and intertribal agencies. The summary memo goes on to state that the two lead agencies, the Corps and the Minnesota DNR, ERM, the contractor for the lead agencies, and Bar Engineering, PolyMet's consultant, disagreed with the broad overall recommendation of the IAP group. Consequently, the final EIS used a different method altogether. They did not take the recommendations of all these other agencies. Instead, the final EIS has an analog method, what has been called an analog method. So this method compared water level fluctuations of the Canisteo mine pit, which is an existing taconite pit in the Iron Range, to water level fluctuations in wells located in its immediate vicinity or at some distance to the mine pit. And the idea was to try and infer what the hydrologic connection is between the pit and these wells by trying to correlate fluctuations in those two areas. Based on that data, there were 4 analog zones created for the FEIS, and wetland acres in each zone were calculated. And there was some effort to discuss the likelihood of impact to wetlands from drawdown in each of those zones. Now, the analog method has many shortcomings, and I know my agency and many other agencies attempted to communicate these shortcomings to the Corps many times. Glyphlix position is that this method can produce some useful information, but it is not in any way a replacement for a quantitative predictive method. In fact, the final EIS does state that indirect effects analysis performed for the EIS were not performed to characterize impacts, but done to inform where monitoring should take place for those areas that were identified as having a potential for indirect wetland effects. So not an effort to predict impacts, but simply an adaptive management solution. At Glyphlix, we believe that an EIS needs to assess past, present, and reasonably foreseeable impacts of a proposed action. Simply monitoring for an impact so that mitigation can be done after the impact has already occurred is a flawed approach. But we failed to convince the lead agencies to do something different other than the analog approach. So Glyphlix, we have been forced to use this analog method in an attempt to provide some information that can be used to predict indirect impacts to wetlands from drawdown, and to provide some information on behalf of Fond du Lac and the will effect determination. Now, back in 2013, we submitted to the Corps an analysis of indirect wetland impacts using the analog method. We modified it some. Our analysis incorporated some additional water level information for wells that the EIS did not use. We obtained these wells and data from the Minnesota DNR mining hydrologist at the time. We urged the lead agencies to incorporate this additional data into the analog analysis method, but this was also ignored. This figure shows the analog impact zones in Glyphlix analysis. They are slightly larger than those that appear in the EIS. Zone 1 is the closest area to the mine pits, where drawdown of 5 to 10 feet would be expected. Zone 2 drawdowns are expected to be between 3.5 and 5 feet. Zone 3 from 1 to 3.5 feet, and the outermost zone, number 4, we would expect drawdown of up to a foot to occur under the wetlands. Here's a map that we prepared for Zone 3 as an example, showing wetlands potentially impacted by 1 to 3.5 feet of mine-induced drawdown. As you can see, these wetlands are hydrologically connected to some of the surface water features, Yelp Creek and the Partridge River, that surround the area where the mine would occur or would be constructed. There's a similar situation for wetlands in Zone 4. There's large areas of potential impacts from drawdown. According to the EIS, these are also many of the areas that would need to be monitored, which seems like a very difficult thing to do over an area like this. This map indicates that wetland drying in this zone, while having the same hydrologic connections of the previous map, also may involve another tributary to the Partridge River, Wetlegs Creek, in the southwestern section of the mine site. Okay, so as I've indicated more than a few times now, Glyphlix is not comfortable using the analog model. So a few years ago, we contracted with the United States Geological Survey to build a groundwater model like the one that was really needed for the project in the first place. Work has recently been completed on a model that looks at the impacts of existing and proposed mines for the Partridge River Basin. The PolyMet project is only one of 5 different projects included in the analysis. And once again, the report, final report, and all the model files are available at this link. The drawdown contours generated from the USGS groundwater model for the Partridge River Basin confirm that groundwater drawdown under wetlands around the proposed PolyMet mine will occur. The cone of depression becomes very steep in this area close to the pits. If we had tried to map them, it would just be a solid black area, so you wouldn't distinguish any detail. But this area in the center has predicted drawdown greater than 16 feet, and it extends or increases to hundreds of feet. The drawdown depicted in this map was calculated by subtracting model files of groundwater elevation, or head files, for the with mine scenario from model files of groundwater elevation without the mine. This difference reflects the drop in groundwater elevation due to the PolyMet mine pits when they are fully developed. Drawdown induced by the PolyMet mine was found to be essentially the same when looking at the model layers representing the superficial deposits as when looking at layer representing the top of the bedrock. Now, there are obviously differences between the USGS model drawdown data and the drawdown estimates for the analog method. This is not at all surprising, given that they are very different methods. And the differences do make it difficult to conduct a direct comparison between the results of each. However, in general, it does seem that drawdown in analog zone 1 and 2 are underestimated. In some areas, this underestimate is substantial. Differences in drawdown estimates in analog zones 3 and 4 can vary. However, we do note that both methods agree that mine-induced groundwater drawdown will occur. These results, both Glyphlix analog analysis and the USGS modeling, do suggest that hydrologic stresses on wetlands due to mine-induced drawdown are likely to be far greater than was estimated in the final EIS. Mine-induced drawdown that extends out to about 1.5 miles from the mine pits is not surprising given what has been seen at other mine pits. So these figures we're taking from a bar engineering memo and show that substantial drawdown in the superficial aquifer extends about 1.5 miles from 2 existing iron ore pits. So these areas in the figures, these large depressions here in the cross sections, are the mine pits, and you can see very nicely defined cones of depression in both of these that extend out about 1.5 miles. This figure I put up here also to give an example of how analog information can be useful. In this case, by providing a reality check on the groundwater model outputs. But again, we would say that analog information alone is not sufficient for impact prediction. So that is the end of what I've prepared. Thank you for your time and attention, and sorry for my problems with the mouse. Thank you.
All right, thanks very much, Esteban. We are going to go ahead and recess for an afternoon break.